So we're going to start our afternoon poster session, but just to remind you, this is poster session 2. Those of you in poster session 3, okay, you need to get your posters in 9 o'clock tomorrow on the Google Drive, okay? Next slide, please. All right. Yes, poster session number 2. We just had a very nice talk, and poster session, next slide. Okay, poster session 2, it's here. Snapshots. Okay, next slide. Okay, just to remind you, snapshots first, poster session to follow. Outside, there will be directly outside of this lecture hall. Next slide. Again, just to remind you the judging criteria. So if you haven't done so, please pick up a poster judging ballot here and a list of names, this list of names who are of the presenters. Anybody need a ballot or, okay, come on up. Come on up and pick that up. The ballot and the corresponding guide to the posters. Okay, so these again, the criteria, and then next slide. All of us are judges. Next slide. And this is what your ballot looks like. Again, if you want to, the basic way you do this, you choose your top 5 in order. And if you want to be eligible for a drawing, okay, then you need to write your name down on the ballot so we know who you are. Next slide. And of course, all the posters are competing for prizes, cash prizes. And in fact, next slide, we have a peer judge drawing from the last one. So this is now our first money is going to be awarded. So here we have our official UN ballot box, which contains securely the poster ballots from the first session. Okay, and so what we're going to do at this time is to draw, to ask an unbiased observer. So, no. So, yeah, I think we'll have Maria Liz Crespo come forward. Yes. Who is not part of the drawing. And so the way we're going to do this, all the ballots are in here, folded up. I'm going to shake them up. And Maria Liz is going to reach in and grab one of these and then hand it to me without looking at it. Pull one out. All right, here it is. Okay. And also, what do we got? What are we drawing?
Mike's money. All right.
Here we go. 20 euros.
Right there.
Okay, so let's see who we have here. If the person is here, you have to be present to win. Have to be present to win. Have to be present to win. Yes, this person is present. Is present. Okay.
Dun. Warmer, colder, warmer. Yeah. Put it back in his pocket. No.
The winner is Xn+1 AXn. Okay. So now we were going to proceed to the next poster session 2.
So everyone note that you are free to use the clicker if you want, or I will click for you. I don't think there's any hesitation in these slides. You kept your file sizes down, but it's up to you. If you want to mess with the clicker, it's your business. If you want me to do it, I will do it. Whichever you're more comfortable with. You just say next slide, okay?
Okay, and click forward impact. Okay, and I will announce you. Okay, so we'll start poster session number 2, and our first poster presenter, poster number 18, is Angie Lau from De La Salle University in the Philippines, and she'll present her poster, which is titled, "A Mathematical Model Offers a Possible Interaction Network That Explains the Effect of Raphanus sativus on Cancer."
Okay, good afternoon.
Yeah.
Which row?
Click one.
Yeah. Well, I already clicked it. Hold. Like hold the click.
Okay, now you.
Okay, good afternoon. Cancer is the biggest cause of mortality worldwide. WHO reported that around 14.1 new cases and 8.2 million deaths are reported cause of death caused by cancer worldwide. And from these new cases, 60% actually occur in Asia, Africa, Central and South America. Alarmingly, these regions also account for 70% of the death caused by cancer worldwide. We know that it's not because they cannot be treated, but mainly because the expensive cost of medication or the side effects caused by the treatment. Henceforth, there are a lot of initiatives then. There's a spark or interest in finding natural product that will serve as a cost-effective or less side effect alternative for cancer treatment. In particular, there are experiments that confirm what? Confirm that Raphanus sativus is an effective thing that can fight cancer. They showed that it's most cytotoxic to breast cancer, next to colon cancer, and leads to leukemia. It won't click to the next slide. So,
Do it again.
okay. So why? Why is it more effective to one and leads to the other? So instead of investing huge amount of money or funding into high-end experiment that you don't know what you're investigating on, we propose that you first gather information from literature mining and establish an initial interaction network that will be used to establish mathematical models that explain why the radish is more effective to one disease and than the other. To know more about how we did it and what are our initial findings, visit me at poster number 18.
I think he can do it for me better.
Okay, and then
Yeah.
have him advance.
Yeah.
You can use the laser pointer if you want, the top
Okay.
button, if you like.
Yep.
Okay, and then you can have him advance. He's going to ask you to advance.
I'm advancing. Okay.
Yep.
Poster number 19 is to be delivered by Madhav Pandey from the Kathmandu University in Nepal, and he'll tell us about his work on value addition of waste ligand from ligocellulosic bioethanol process.
Hello, everybody. Everyone nowadays is interested in renewable energies. Bioethanol is a renewable fuel that is supposed to directly replace gasoline, fossil gasoline. Currently, we are producing bioethanol from corn and sugarcane, which is not much so sustainable and viable. So people are looking for more abundant feedstock to produce bioethanol. So, one of the options is lignocellulosic biomass. However, the process that is used to convert this feedstock to ethanol utilizes only the cellulose and hemicellulose and converts this to the ethanol and leaves lignin as it is. So nearly 1/3 of the feedstock is wasted or not utilized. Next, please. Lignin is a complex biopolymer with varieties of functional group attached with it and varieties of bonds. It is difficult to break down. However, if it can be broken down, as the structure suggests, it can be a very prominent or suitable source for industrial chemicals. So what we did is that we tried to break it down in presence of alcohol to have phenol and its derivative. Next, please. So this is what the experiment did. We extracted the lignin, purified it using washing, filtering. We characterized the lignin samples, depolymerized that using autoclave reactor, and we characterized the lignin oil or the depolymerized products. Next, please. So we have several characterization curves. I only listed few of them, and this is the FTIR spectrum of the lignin that we obtained, and it shows that the structure is nearly similar to the commercial lignin samples from other processes, and we could reach up to 88% of the conversion efficiency, which in fact was the function of reaction time as well as the temperature. And our analysis showed that there are significant amount of phenols present in the product. Thank you. I will be happy to meet you at the project.
That's me.
Top button is the
Pointer.
pointer and then left and right. Okay. Poster number 20 is to be delivered by Nelud Siubanu from the Nicolae Tistiminciano State University of Medicine and Pharmacy from Moldova, and he'll tell us about his work on synchronization and message transmission of 2 quantum dot lasers.
Okay. Well, this work was done in collaboration with my colleagues from Technical University of Moldova, Spiridon Rusu and Vasile Tronciu. So the transmission of information and communication play an important role in nowadays. For example, Bob wants to transmit the information to Alice. So one hacker can connect to the environment or connection and they can extract the information. The main questions that appear in the transmission of information is how to improve privacy and security in data transmission. It was many models were developed. For example, it was proposed to use fibers between the sender and the receiver, or for example, to use electronic circuits, various encoding protocol, filtering, and as well as chaos-based communication techniques were proposed. So our model consists of 2 DFB lasers, so based on quantum dot lasers, master lasers, and slave lasers. So the message is encoded in the chaotical behavior of master laser and is transmitted to the slave laser or Alice. So this is the scheme for quantum dot lasers. This is the dynamics, the equations that describe the dynamics of or the evolution of our laser. And here what we have, initially we have the message in the picture A that we want to send. In the picture B we have the chaotical behavior of laser, and picture C we have the encoded message in the profile of master laser. And finally, after the transmission and decoding, we have unfiltering, we extract the message. So you can see if you compare A and B is the same messages. The main question is why. Okay, thank you.
Is the laser pointer, and he's going to advance the slides. Yeah. Okay, so just the top one is for the laser, and I'll.
Okay. Oh, yeah.
Poster number 21 is to be delivered by Bhumika Thakur from the Institute for Plasma Research in India. She'll tell us about her work on time delay as a possible tuning parameter for frustration in neural networks.
Thank you. Hi, everyone. So frustrated systems are the systems where all the interactions in the systems cannot be simultaneously satisfied. For example, consider this triangle here where all the edges represent antiferromagnetic interactions. So if I have a downspin at A and an upspin at B, then interaction between A and B is satisfied. But if I put an upspin at C, then the interaction between B and C is not satisfied. And if I put a downspin at C,
then interaction between A and C is not satisfied. So systems are called frustrated systems, and whether a system is frustrated or not, it depends on the topology of the network. For example, the triangular lattice here, it's frustrated, and such kind of configurations are very common in nature. For example, the grid cells in human and rodent brain, they form firing pattern in form of triangular grids. So frustration has been observed in many physical and biological networks, such as spin glasses, genetic neural network. Next slide, please. Frustrated systems can often be modeled by the system of repulsively coupled oscillators, which are configured in suitable configurations. And here the role of repulsive coupling plays the role of antiferromagnetic interactions. And the dynamics is given by this equation here. So since in all real systems, signals take finite time to propagate, the question that we are interested in is what happens to the collective states of frustrated system when we have finite time delay interaction between individual elements. And the answer that we find is that time delay does indeed have a great impact on frustration parameter, and we can use this property in neural network system for control switching between multistable and synchronous state. Thank you very much. I hope you come to my poster so that we can talk more about it.
Thank you. Put it on your badge here. And top button is the laser pointer, and left and right are forward and back with arrows. Okay? And then I'll introduce you. Poster number 22 is to be delivered by Kanayo Oguzi from the Federal University of Technology, Owerri in Nigeria, and she'll tell us about her work on enhancing anti-corrosion properties of paints using natural extracts.
Thank you. Yeah, corrosion is a destructive of metallic parts and structures. Corrosion also, the cost of cleaning up corrosion is very expensive. Here you can see pipeline being corroded, and this is an oil spill. So the cost of cleaning the oil spill is expensive. Most of the anti-corrosion additives used are toxic and expensive. Hence, there is a need for us to develop a new class of anti-corrosion additives, which is non-toxic and inexpensive. So that's why we had to look at natural product of plant origin as source of low-cost, eco-friendly inhibiting additives. And these are the phytochemical components in the plant that makes it inhibitive. Now, we tested for these plant extracts as corrosion abilities using gravimetric techniques in the lab. And from our plot, we find out that plant extracts do affect corrosion in different ways. And you can now say that corrosion, you can use plant extracts for anti-corrosion inhibiting. And further studies can be exploited for such. Meet you at poster 22. Thank you.
The laser pointer and the arrows forward and back.
Okay.
Introduce you.
Okay, thank you.
Poster number 23 is to be delivered by Mohammad Reza Orari from Shahid Beheshti University in Iran. He'll tell us about his work on experimental characterization of an optofluidic liquid or liquid cladding waveguide.
Okay. This is the top view of an optofluidic waveguide. It is the same as the normal optical fibers, but it is delivered by the optical pulse is delivered using the liquid mediums, where, as you see in the cross section, the refractive index of the cladding ones are less than the core medium. As seen by the TIR simulation, the ZMAX, we can deliver light from the first excitation port to the next one. What we have done and what we are interested is to increase the refractive index distribution in the core medium, because after a while the water and the core medium diffuse into each other, and we won't have a sharper refractive index profile. This is our setup, what we use, and there are 3 steering pumps and 1 microchip and the optical power meter. This is what we have fabricated, the microchip and the setup, and this is our result. It is shown that higher rates of core flow results in better waveguiding, and it is true for when we increase the rate of the cladding flow rate. This may lead to the better characterization of these optofluidic waveguides. Thanks for your attention.
Poster number 24 is to be delivered by Enoch Wembabazi from the National Crops Resources Research Institute in Uganda. And he'll tell us about his work on Fourier transform infrared spectroscopy for fast-tracking affordable biocatalyst production.
Thank you. Now, a lot of methods are currently used in studying materials, but for me, I zeroed in down on Fourier transform infrared, simply because it has been widely known to be much faster than all the other methods. So you're able to generate actually so many spectra within very few seconds, and you can interpret so much data within that, and you're able to know what your material contains. Well, when you even further couple your Fourier transform infrared with attenuated total reflectance, then you can lose so much data. You can actually get so much data from fluids and solids of this particle, and you generate spectra similar to this. So each of these peaks here you see represents a chemical bond between 2 atoms in your material. Right, so the heterogeneous biocatalysts we synthesized were from agricultural wastes, such as sawdust, eggshells, and common table sugar, sucrose. And what you see here, over here, is the process of heating eggshells strongly. And when you do that, this is the material we got. We heated them at several temperatures, right? And of particular interest is this region between 1,500 and 1,000. These strong peaks you see here correspond to calcium carbonate. Now note, this is raw eggshells, but as we heated them strongly, as temperatures increased, you have thermal decomposition and subsequent emergence of another bond here, calcium oxide, which is the active catalyst we're interested in anyway. So we tested the active catalyst then on transforming expired sunflower oil into biodiesel. That's what you get here. The higher catalyst synthesized at higher temperatures had the highest amount of biodiesel. And this confirms what the FTIR spectra were giving us. Thank you.
Sí.
Okay.
Okay.
Poster number 25 is to be delivered by Federico Abeja from the Universidad de la República in Uruguay, and he'll tell us about his work on control and self-similarity in coupled chaotic maps.
So if you had to choose just one dynamical system with which to explain chaos to someone completely unfamiliar with the subject, you'd actually do very well to choose the logistic map. Because you see, this is a very simple, one-dimensional quadratic map. So in goes x sub n, out goes x sub n plus 1. And this actually started as a first approach model to population dynamics. And yet by varying its only parameter alpha from 0, which is not here, to 4, we can see the asymptotic solutions to the system go from fixed points to periodic orbits, and all the way up to chaos when alpha is greater than about 3.5. So we wanted to study the dynamics of two of these systems when they were coupled using a linear coupling that goes from 0 to 1. And we want to know what happened. So we've made some numerical simulations, and here we can see the periodicity of orbits. So the colors correspond to different periods, black to chaos, as a function of one of the map parameters and the coupling constant when the other map is fixed to a chaotic regime. And we can see that even for relatively low coupling constants, when both maps are chaotic, we get periodic solutions, which means the system kind of controls itself. But we went a bit further, and we wanted to study dynamics as a function of initial conditions. And we can see that the system presents multi-stability, which means that for the exact same parameters, different initial conditions will actually lead you to different attractor basins. And what's most interesting about this is that if you plot the structures leading to different attractor basins, that is what these colors are, you actually get self-similar structures. So the structures in initial conditions map are fractals. So thank you very much. I'll be happy to explain more about it in my poster session and answer any questions you may have. Thank you.
And the forward back.
Top button is the laser pointer, forward, back, and I'll introduce you. Poster number 26 is to be delivered by Vikas Pandey from the Indian Institute of Technology, Bombay, in India, and he'll tell us about his work on identification of a nonlinear stability boundary observed in nuclear reactors.
I started to work on this topic because I write plays and I love drama. And the operation of these nuclear reactors are full of dramatic accidents in past. And why do you care? Because you love your life and you are living with 440 nuclear reactors around us. I am working on one kind of instability, and these are the accidents which occurred because of that instability. So this is the nuclear reactors, and in this reactor water comes here, it gets heat from neutron generation and goes as steam, and it went to turbine and produce power. These are the equations for the process. The instability I was talking about, neutron coupled thermal hydraulic instability, was analogous to Hopf bifurcation, and if there is a Hopf bifurcation, then there will be a limit cycle. If we have unstable limit cycle in our system, then it is dangerous situation for us, because if there is a large perturbation in our system, it will grow and it is a dangerous situation for us. So what I did, I plotted a nonlinear stability boundary at which the unstable limit cycle disappears, and this region is this region is considered nuclear engineer as safe, but I consider that because of unstable limit cycle it is unsafe, and this region is stable, and beyond it we are in a safe zone. So please visit my poster to know about Hopf bifurcations, limit cycle, instability, and also to know about why you should not join them. Thank you very much.
Poster number 26 is to be delivered by Benjamin Ponbun Jaroenchai from the Kasetsart University in Thailand. and she'll tell us about her work on dynamics of thin, multi-arm spiral waves in excitable chemical media.
Okay, thank you for the introduction. One of many reasons which make people interested in the spiral wave is that it connects somehow to some cardiac arrhythmia. In this case, the spiral takes the control of heart contraction because it has a frequency 4 to 5 times higher than normal. In this case, the heart pumps the blood to the body with a high frequency but lower efficiency, and then it can lead to sudden cardiac death. So the spiral should be removed. Before we remove it, we have to generate it first. So we use the BC reaction as a model system to study the spiral wave. Because the preparation and the wave observation are convenient. And from this figure, the excitable is in red and the excited waveform is in blue. Our study, we show the initiation of 3-arm spiral wave in BC reaction by using a partition method. And we study the dynamics of them. We found that in the first term, the distance and the angle between arms are not equal, but finally it will be same. This is the self-organization. If you want to know the detail, please come to my poster. Thank you for your attention.
Top, there's a laser pointer, forward and back. Okay, I'll introduce you. Poster number 28 is to be delivered by Leonardo Dominguez Rubio from the University of Havana in Cuba, and he'll tell us about his work on experimental platforms for the controlled growth of granular piles.
Granular materials have been explained by scientists from many years ago, but mainly the growing of piles. But there are some things, like the transition between growing regimes from continuous to intermittent, that haven't been explained by theoretical models. To do this, to provide an insight about this phenomenon, we propose an experiment which is capable of controlling all the variables involved in this process, but mainly that we can ensure the supplying height of the material, what makes us maintain constant the kinetic energy of the grains when they reach the top of the pile. For doing this, you see, we use a laser for detecting the position of the top of the pile. This picture was our first attempt of a 3D configuration, but it's not the one we are using. I'm using it because it's more explicative. But what we are using actually is a two-dimensional pile growing between two glasses, which is known as Hell-Shaw cell. This is our complete experimental setup, which brings us a good problem, which was too much data. So we couldn't use MATLAB or Mathematica for analyzing the videos. So we have to make a program in C++ and OpenCV very efficient, which allow us to process all that information in really short times. Some results we had were, for example, that the supplying height was constant. We could calculate the area of the pile, the angle of the pile in every frame, but most important, we found a linear dependence of the transition with the supplying height, something that can help us to build a theoretical model for explaining this phenomenon. Thank you.
Okay, so top is the laser pointer, forward and back, and I'll introduce you.
Thanks.
Poster number 29 is to be delivered by Mohammed Farad from the Lahore University of Management Sciences in Pakistan. He'll tell us about his work on designing zero-index materials using all dielectric photonic crystals.
Refractive index of a material is the ratio of speed of light to the speed of the wave in that material. which is really not the speed of energy, but it's the speed with which the phase moves in the material. So a zero index material is a material in which the phase moves very quickly in the material. So whatever is the phase here, the same phase is here. So because of that, zero index materials are very important because we can have, say, one-way transmission because in this case the phase is same, but not in this case. Or we can mold the phase fronts of the waves with these materials whatever way we want. So the conventional approach of designing these materials is mixing a dielectric and a metal material, say they are both finely grained. So the idea is that we can cancel the positive permittivity of the dielectric with the negative permittivity of the metal so that we can have almost zero permittivity. But that has its own problems. First, and the major one is that the impedance of this material becomes infinite, which is the ratio of the permittivity and permeability, because we are canceling the permittivities and not the permeabilities. So because of that, the energy coupling to this is very difficult. So the more recent approach is to use photonic crystals, which are periodic arrangement of only dielectric materials. And the idea is to calculate the dispersion diagram and see what frequencies are possible in this material where the wave number is zero. Not the index, but the wave number of the material is zero. So that's what this work is focused on, where we have investigated systematically the conditions under which a photonic crystal can behave as a quote-unquote zero index material that can be used for application. So I would be happy to answer any questions in the poster session.
This is the laser pointer at the top.
Okay.
Advance and back.
Okay.
Okay, and I'll introduce you.
Thanks.
Poster number 30 is to be delivered by Nina Ileva from CISA in Italy, and she'll tell us about her work on the role of membrane composition in vision.
Hello, everyone. So vision is considered the dominant sense of humans. Okay. And in order for us to see, recognize, or perceive something, the light that enters through our eyes gets converted into neural impulses that get sent to our brain for us to make sense of the information. How does this happen? It happens in a series of steps known as a phototransduction cascade. So, okay, how does vision work? So, once the light enters through your eyes, it gets projected onto the retina, which is loaded with millions of photoreceptor cells, which are mainly two types, rods and cones. So, cones, they detect fine detail and color, while the rod cells, they are more numerous, more light sensitive, and they register a grayscale of black and white. I want you all to memorize how a rod cell looks like, because now I expect you to know that what is on the cover of this magazine is actually a rod cell. This big pink thing is the outer segment of a rod cell, and it consists of disc membranes that are surrounded by the plasma membrane. Embedded inside both the disc membranes and the plasma membrane, there is a light-sensitive protein known as rhodopsin. Rhodopsin actually enables vision through activation of the phototransduction cascade, and it behaves different in the disc membranes and in the plasma membrane. It is known to be functional only in the disc membranes, and we want to know why. Could it be due to the fact that the two membranes have different lipid compositions? In order to study this and to answer this question, we developed a model, which is a coarse-grained model for the protein membrane system. Instead of including the membrane like this, we put a membrane potential. And if you want to know what we found, just come and see my poster. Thank you.
poster number 31 is to be delivered by Fatemeh Rajab Asadi from the Shahid Beheshti University in Iran. And she'll tell us about her work on fabrication and functionalization of magnetic microswimmers for biomedical applications.
Hello everyone. My presentation is about fabrication and functionalization of magnetic microswimmers, in particular magnetosperm for biomedical application. In first step, what is a microswimmers? Magnetosperm is magnetic microswimmers consist of an ellipsoid head, magnetic ellipsoid head, and trapezoidal flexible tail, mimic to a sperm cell, which can swim by propagating a planar wave in flexible tail. Motion of magnetosperm is due to thrust force generating based on a oscillating flexible tail. We use 2 pair of Helmholtz coil to produce oscillating weak magnetic fields to swim this magnetosperm and detecting swimming by microscopic and tracking and feature tracking algorithm. We measure speed of swimming of microswimmers, vice versa, frequency of external magnetic field, and provide this diagram by a study physics of these microswimmers. We can use them effectively in biomedical applications. Thank you.
Do you want to clip it? Or? Yes.
Okay.
The final poster in this poster session 2, poster number 32, is to be delivered by Zahra Adadnezad from Shahid Beheshti University in Iran, and she'll tell us about her work on the characterization of bismuth, YIG, yttrium, something, garnet, magnetic garnet powder prepared by auto combustion method.
Hi everyone. Bismuth with the following chemical formula are interesting soft ferromagnetic material. This type of garnet, because of high Faraday rotation, high Faraday and Kerr rotation, together with low optical absorption in optical wavelength visible to IR, have a high quality factor. So this material have attracted attention in many applications such as electronic devices, microwave communication, and light control device such as isolator, circulator, and waveguides. In this study, we present the production of bismuth with the following formula by Sojal auto-combustion method. This method is simple and inexpensive with a heat treatment at various annealing temperature, as shown in this chart. The XRD analysis confirmed that complete garnet phase has been formed in the powder annealed at 900 degrees Celsius. So with this temperature and with this heat temperature and this method, it's suitable to complete garnet phase to be constructed. On the other hand, magneto-optical Kerr measurement and VSM analysis show appropriate response to this powder, to these magnetic powder samples. Thanks for your attention.
Okay, so that concludes poster session, snapshot session number 2. Let's now proceed out to viewing the posters. And before we do that, let's give everyone, the presenters, a nice round of applause.